Now, the last question. Question 5. Unpolarized light with intensity of 25 watts per meter squared is sent into a system of 4 polarizing sheets with polarizing directions at angles theta 1 equals 40 degrees, theta 2 equals 20 degrees, theta 3 equals 20 degrees, and theta 4 equals 30 degrees. They ask us for the intensity of light that emerges from the system. So drawing this, without showing too much of the answer, we have light coming in through here. The equation to find the intensity of an object will be I equals theta naught times cosine squared of phi. What is phi? Well, phi is, in this case, for the first sheet, we will lose 1/2 of the intensity. So the original intensity times 1/2. That will be the original. After the light goes through the first sheet. Next, we actually use this equation, cosine squared phi. Phi equals this angle. So how do we measure this angle? Well, we're given theta 1 and theta 2. So this angle will equal, this being a right angle, will be 90 plus theta 1 minus theta 2. That will be our phi. And that is what we plug into the equation. So we will have the intensity equals the original intensity times half. You lose half going through the first sheet. Going through the second sheet, we will lose cosine squared phi. Phi again is theta 1 plus 90 minus theta 2. And that's what we have here. Cosine squared of theta 1 plus 90 minus theta 2. We multiply by the next sheet. Phi in this case equals 180 minus theta 2 minus theta 3. And that is what we plug in. Cosine squared 180 minus theta 2 minus theta 3. Lastly, theta equals 270 minus theta 3 minus theta 4. And that is what we multiply. Cosine squared 270 degrees minus theta 3 minus theta 4. We're given intensity, so we plug in for the original intensity, 25 watts per meter squared, and we plug in all the degrees. Plug and chug, we get 0.498 watts per meter squared, which is actually a lot loss. That is our answer. B, 5B, in the figure, we're given this figure. Light is incident at an angle of theta 1. So light will hit this barrier at an angle of theta 1, which equals 40.1. On a boundary between two transparent materials, some of the light will travel down through the next 3 layers. Some of the light will take this path here, while some of it reflects upward and escapes into the air. Some of the light will actually reflect and escape into the air at this angle. We're given all the ends for all the materials. N1 equals 1.3, N2 equals 1.4, N3 equals 1.32, and N4 equals 1.45. They ask us for theta 5, which is this angle, and theta 4, which is that angle. So, little geometry. We know that the angle of incidence will equal the angle of reflection. So this is theta 1 and this is theta 1. We have 2 parallel lines here. This is a parallel line, and these 2 lines are parallel. So this angle will equal this angle. This is also theta 1. This is the angle we will use when we find theta 5. Going down the materials, this is theta 1. It enters the second layer, and this we will call theta 2, this angle here, theta 2. This angle will enter material 3 enter material 3, hold on, at this angle. This will be theta 3, which will also be two parallel lines here. This will also be theta 3. So it will enter the next material at this angle, and I'm sorry, it'll be in the third layer at theta 3 and enter into the fourth material at an angle of theta 4. So we have an interesting relationship here. We have theta n1 sine 1, again all this is Snell's law, n1 sine 1 theta 1 equals n2 sine theta 2 equals n3 sine theta 3 equals n4 sine theta 4. We will come back to that in a second. First, at what angle will it enter the air? Well, we know that this angle is the angle of incidence for light leaving this material, leaving n1, leaving material 1. That will give us n1 sine theta 1. We have theta here, and that will enter into the air at angle theta 5. Simple Snell's law, n1 sine theta 1 equals n air sine theta 5. We plug and chug, 1.3 because that's given, sine 40.1 also given, n of air is always 1, sine theta. We get the theta of 5 equals 56.86 degrees. That is 1. Next, we find theta 4 at the bottom material. So we have this interesting relationship. We can actually skip the middle part and just set n1 sine theta 1 equal to n4 sine theta 4. We solve for theta 4, and we will get 35.27. And that is our project.